Hello there, my name is Sam, and today I'm going to teach you about differentiation and derivatives. We're going to look at the chain rule, the product rule, and several examples. If you're interested in that, stay tuned. If you're not and you want something more advanced, you might check out one of my other Mathematica tutorials. Alright, so we are going to calculate derivatives from within Mathematica, but we're also going to talk about the rules and how you would do this by hand. Okay, I'll make myself smaller and move my head out of the way, and we'll get on with it. So I am in this booklet that I've made, a YouTube course in Mathematica, which is available on my website. I'll put the link to that in the description below, and we'll open up a Mathematica notebook. Now this is an exercise that I did on PCA, so if you're interested in that, check out my last video. Alright, so we'll open up a new notebook, increase the magnification to 300 so we can see it, minimize that, and we'll talk about derivatives. Okay, so our first problem says differentiate the following functions using Mathematica, and then we're given some code. Alright, so let's just start by entering this. So this is to take the derivative of x squared with respect to x. Alright, so I just enter that, shift enter, and I get 2x. Okay, now the rule for differentiating a polynomial is that if I have x to the power of n, then I take this exponent, put it in front, and I subtract 1 from it. Alright, so just as we have 2 there, if I'm to differentiate this by hand, I place that 2 as a coefficient in front, and then I subtract 1 from 2 and let that be the exponent of the derivative. Alright, so let's try a more complicated example. X cubed. Alright, if I differentiate x cubed, I get 3x squared, which is precisely according to the rule I just explained. Okay, now what about x to the 4th? Alright, 4x cubed. Now, if we have a coefficient other than 1 in front of this, let's put minus 5. Okay, now this derivative will be minus 20x cubed. Okay, because what I do is I take this 4 and multiply it by the coefficient in front, and I would get minus 20, and I subtract 1 from the 4. Alright, so let's do this, shift enter, minus 20x cubed. Okay, now if you're thinking of this as a differential operator, the d symbol, which is often dy on dx, or sorry, d on dx, to take the derivative. Okay, so this constant can move through the operator. So I'll just show you. Right, I'll copy this. What I'm saying is that this can move through the operator to multiply on the outside. Okay, and these will be the same. Alright, so there we have it. Now, if we have a more complicated example, say, what about the polynomial minus 5x to the 4th plus 3x squared minus 7. Okay, we can differentiate a polynomial by looking at each of the terms individually and differentiating those and adding the result together. Okay, in other words, this will be the same as the derivative of this one plus the derivative of 3x squared. Okay, so I'll write that in, 3x squared, and then plus the derivative of the constant term minus 7, which is 0. Alright, these will be the same. And we have minus 20x cubed plus 6x, which Mathematica likes to write in reverse. Okay, so that's basic differentiation. Now let's look at some more involved examples. So we'll scroll down in this PDF that's available on my website, and we'll differentiate some of these. Okay, now, so we've already done a lot of examples like this. Let's just choose one, which will be this number C. So we write our D with respect to x, and then I'll differentiate x to the fourth minus 2x cubed minus 2x squared. Shift enter, and here is that derivative right down here. Now, you're probably watching this because you're new to the concept of differentiation. Okay, so you might not want to do this with the full version of Mathematica. All of this works with the phone app or the iPod app known as Wolfram Alpha. Wolfram Alpha is a great tool. All of these commands work in Wolfram Alpha, and you can, provided that you have an internet connection, you can be sitting on a beach, for example, and calculating some of these things. All right, so Wolfram Alpha is handy. Okay, now let's go on to talk about cos. The derivative of cos is minus sine. The derivative of sine is cos. All right, so if we are to differentiate cos, which is short for cosine, x plus x, the derivative should be minus sine of x plus 1. All right, so the 1 comes from differentiating x. Shift enter, let's have a look. Yes, that's exactly what we said there. Okay, now let's look at the next one, which is g. Right, because in this one we have our first opportunity to use something called the chain rule. Okay, so I'll come down in a new cell. Now, f equals sine of 2x minus x. Okay, so the chain rule, let's write this in comment form. Chain rule. And I like to use Leibniz's notation rather than Newton's notation because I find it better for helping out with your memory of the rules. Okay, so the chain rule says that the derivative, so I'll write this in comment form, so df on dx, as we tend to write in calculus, equals, now you know what, I'm going to put this in a fraction form because even though derivatives are not fractions, it is helpful in aid to memory. So I'll open up a palette, Basic Math Assistant, okay, and it's right here, and I'm going to express this instead using the fraction button. So I'll put the dx in the denominator. Now all of this is just in comment form. Okay, but it should be helpful for describing this to you. All right, now df on dx is in the derivative of this function with respect to x is equal to, by the chain rule. So what I do is I make two derivatives, okay? And now I'm thinking about these as if they were fractions even though they are not. So I'll get rid of this denominator and I'll get rid of this numerator. Okay, now you see the way I've set this up is I have the df on the top matching this and the dx on the bottom. And now I ask myself, what other function do I have inside this? Okay, there's another function. It's the function that multiplies x times 2. Okay, so I can introduce a new letter to represent another function, all right? And I'll put it let's call it u. Okay, so du and du. Now, look, if you were for a moment thinking of these as if they were fractions, which they're not, okay, if they were fractions, then the du would be able to cancel. Right, now that is in aid to memory of the rule that says that df on dx is equal to the derivative of f with respect to u times the derivative of u with respect to x. right? So these are derivatives, they're not fractions. But if you were thinking of them temporarily as if they were fractions, you would be able to cancel a du, right? Okay, so that's in aid to memory of this rule, which is the chain rule. Okay, and we'll say u equals 2x in this case because we've let it be 2x in order to take this derivative. All right, so next, let's carry this out. Okay, so we have f is equal to sine. Well, look, let's just, you know what, I'm going to call this g. All right, I'm going to call that g, and then I'm going to call f sine of 2x, okay? Because we want to first focus on the derivative of this, sine of 2x. Okay, so now if that is the case, then I have sine of u, because we let u be equal to 2x. Sine of u, and then we're going to apply the chain rule. All right, so the derivative, all right, so I'll copy this out. What I'm doing is I'm showing you how you would do this by hand, right? But then we can go and calculate the same things in Mathematica. All right, so df on dx, so the derivative of this with respect to x is equal to df on du. All right, so we'll say equals, I'll copy this and replace df on du. All right, so the derivative of sine of u with respect to u is cos of u. So change this into cos of u. All right, now the derivative of u with respect to x is, all right, so this is a differential operator operating on u, but u was 2x. Okay, so we can come over here, copy that, paste it. Let's get rid of the palette, we don't need it. Okay, so now we should, now this is a multiplication in between those, okay? All right, now we should differentiate 2x with respect to x. Okay, so this is, these two things are the same, so this is just equal to 2. Okay, and now we're almost done differentiating this sine of u. It's nice to put this 2 in front so that you don't get it confused with being inside this function cos. All right, so I'll change that and put it in front. And then remember that u was equal to 2x. Okay, so we'll replace that back in. All right, now this is the derivative of f with respect to x by the chain rule. Now, we wanted to differentiate this function g, which is sine of 2x minus another x. Okay, so now let's write. Now all of this, I'm not intending to execute this in Mathematica, I'm just writing this to imitate how you would do this by hand. Okay, now dg on dx is the derivative. All right, so I'll write that this way. So differentiate this function right here. Okay, so next there is a rule that says when you have a sum of two things or a difference and you're differentiating that sum or difference, then the derivative is the sum of the derivatives or the difference of the derivatives. Okay, so I'll do that just right here. Copy, okay, minus the derivative of x. Okay, so that's what I'm trying to say. You can break that up into two derivatives that are added together. Okay, now notice that we have already calculated this one, right? So let's replace that. Now that derivative was 2x from the above calculation. Okay, so 2 cos of 2x, that's what we got. All right, now we have to differentiate x with respect to x. That's easy. It's just 1. Okay, so 1. All right, and let's reiterate what we found. And we'll say the derivative of sine of 2x minus x with respect to x, the WRT for short, is equal to 2 cos of 2x minus 1. Now, let's put a comment around all of this, okay, because we were just writing a comment. And now it's going to turn turquoisey color. All right, now let's repeat this calculation using Mathematica's built-in derivative function. Okay, now that was the uppercase D, and then we put with respect to x. What were we differentiating? We were differentiating this function right here, sine of 2x minus x. Okay, shift enter, let's try it out, and we get minus 1 plus 2 cos of 2x. Okay, that's exactly equal to what we found doing that by hand. All right, so that's one of the most basic applications of the chain rule. Now, let's go down and have a look at some other things. All right, so the next one is log of x. Now, usually in mathematics, when you see a log and it doesn't say what base it is, in mathematics that's usually base e, which is the base of the natural logarithm, known as Napier's constant. Okay, so, but I think the e must be for Euler, because Euler made great use of that number in his extensive work in mathematics. All right, so d, now log x. Okay, in Mathematica I don't need to say what base I'm talking about if it's just the natural log. All right, so now we can put in with respect to x, and I'll show you this will be 1 on x. All right, there we have it, semicolon on that one. Okay, 1 on x. So the derivative of log of x with respect to x is 1 on x. Now, if we subtract x cubed and do this problem h, well, you can see 1 on x minus 3x squared is the derivative of that function. Okay, so these are the basic, some basic examples in differentiation. Now, let's go down and talk about the, well, this is just another example in the chain rule, so I'll leave that one to you. And let's go down and look at the product rule, okay? All right, so the product rule. Now, let's write this in comment form. Product rule. Now, the product rule talks about the derivative of the product of two things. Okay, so I'll go back and find a fraction. All right. And remember, these are not fractions, but it is an aid to memory of the rules of differentiation that we can use Leibniz's notation and imitate the way things work with fractions. Okay, so what this is saying, I'll put a bracket around that numerator to make it extra clear that we're talking about the derivative of the product of u and v, right, which may be functions of x. Okay, so the product rule says that this derivative is, now I put the v in front because it helps later when you try to remember the quotient rule. Okay, so I suggest putting the v in front. So v du on dx. Okay, so copy this, du on dx, as in the derivative of u with respect to x, right? So v times the derivative of u with respect to x, and then plus the other way around. Okay, so I'll copy this, change this into a U and this into a V. Okay, and so we can get rid of the brackets because it's pretty clear what we mean there. So the product rule says that the derivative of the product uv with respect to x is equal to v times the derivative of u with respect to x plus u times the derivative of v with respect to x. Okay, now let's have a look at this example right here where we have a product of two things that we are asked to differentiate. Okay, so we would set out, we would say, let u be equal to x cubed plus cos of x, full stop. Let v be equal to sine of x. Okay, now that we've set those out, how would we do this by hand? So let's write this out. Now we first of all might like to write down the product rule. Okay, and in our case, we are differentiating this times this, sine of x. All right, now we said v is equal to sine of x, so I can just go and put the v right there, which is sine of x, and then cos of x plus x cubed was u, so copy that and put it where the u was, but I can also do the same up here. And sine of x is getting differentiated there. Okay, so this is what we would do by hand. All right, now let's move down to the next line and simplify these calculations. Okay, so I'll copy this. And let's see, we are differentiating x cubed plus cos of x. Now, that is 3x squared minus sine of x. Okay, so I'll write that. 3x squared minus sine of x, because the derivative of cos with respect to x is minus sine of x. Okay, now over here we have to differentiate sine of x. So the derivative of sine of x is cos of x. So just write that in its place, cos of x. Okay, now that looks just about done. If you want to, you can possibly do a little bit more simplifying by, expanding and collecting like terms. But that is basically correct at this point. Okay, so now let's do this with Mathematica's built-in differentiation function. But we will say that this is a comment now. Okay, so I'll put the bracket asterisk bracket to make that a comment. And what were we differentiating? This product right here. Okay, so I need d comma x, and then I'll pop that in there and shift enter. Okay, there we have it. So you can see that this indeed matches what we have there, and this matches what we have there. Okay, so that's the product rule in action, and a verification by Mathematica's built-in functions for that. Okay, so that's about all I have for you for now. Now I'll just show you, this is my booklet, a YouTube course in Mathematica, and it contains a lot of hints about some of the things you might learn. So kind of like a cheat sheet for various things in extremely brief form, and then it has a lot of exercises at the end that I'm doing on YouTube. Okay, I may eventually go through and talk about some of the things within the first few chapters as well. I'll think about it. Okay, but this booklet is available on my website in the description below. Okay, thanks for watching, and I'll see you next time.